thank you very much for joining us today, and I'm going to hand over to Gareth.
Okay, thanks, Lucy. Yeah, good morning. My name's Gareth Wrench. I've got a couple of roles actually. So I'm working as a program consultant within the strategy unit as part of trying to establish the Decision Support Unit network and the Decision Support Unit Centre. But half of my week, I'm also the Associate Director for Public Health England's Local Knowledge and Intelligence Service based in the West Midlands. So I've got a couple of split roles. And I'm just going to be hosting and chairing this event this morning. Just in terms of format, this is very much a sort of think piece session, drawing on insight from three colleagues who are working at the cutting edge of present day health and care analytics. So we've asked them to sort of gaze into their crystal balls to try and explore how they think this might change over the next few years or so. So it's very much intended to be a sort of informal, thought-provoking session to stimulate a bit of discussion and debate. And it's a key opportunity to hear some views from our analytical experts. As Lucy mentioned, we've got three key speakers to kick off proceedings, but they're all going to approach this from three slightly different perspectives. So we've got Mohammed, who's a principal consultant in the strategy unit, who's going to be talking a little bit about how analysts involved with artificial intelligence in the future need to think about its wider evaluation and not just to focus on the technological aspects. Then we've got Stephen Wyatt, Head of Strategic Analytics in the strategy unit, who's going to be taking a broader perspective and outlining what he sees as three really positive changes that are on the horizon in terms of health and care analytics. And then we've also got Julian Flowers, who's the Head of Public Health Data Science at Public Health England, who's going to be talking a little bit about how he sees the future from more of a data and a data science angle. And the session itself will involve key consideration of some of the major issues, challenges and opportunities facing health and care analysts in terms of things like future skills, technology, software, data and its application. Just at that point, I'm going to hand over to Mohammed, who's going to take you through a few minutes just talking about evaluating artificial intelligence, AI interventions. So over to you, Mohammed, at this stage.
So thank you very much for the opportunity to kind of discuss this with you. It's interesting that it's under the title of the future of analytics, because the notion about artificial intelligence actually goes back all the way, at least to the early 70s. The notion of expert systems replacing human beings, particularly in the medical field. So next slide, please. So before I kind of move into the evaluation piece, if I can just set the scene a little bit with a specific example. So I've been involved in the development of a computer-aided risk scoring system, which uses routine clinical data in acute hospitals to provide real-time estimates of the patient's risk of death and sepsis. The scores will use national early warning scores, which are a standard score for hospitals in the NHS, and routine blood tests, which are also kind of a consistent set of blood tests across acute hospitals. So potentially exciting in the sense that it's scalable to all NHS hospitals. And when we did the external validation work on the underlying model, the C statistics were healthy from 0.8 onwards, and these were externally validated. So if you want to find out more about this, there is a web link there, and we've done a lot more to it than what's on the slide. So if it is of interest, please do have a look. But I want to use as a case study really that often analysts will see their role as being, well, I'm going to try and develop a high-performing predictive analytical system, or a score or algorithm, and this might be a case in a kind of a case in point really. So what I want you to kind of bear in mind is that is just the starting point really. There are a lot more things that I think analysts have to get engaged with when they're thinking about AI related or computer aided decision support systems. Next slide, please, Gareth. Thank you. So just a broad definition of AI. AI, the term is used to describe a range of techniques where we think computers are performing tasks which are typically thought to require kind of human capability of reasoning and problem solving. And we're all living in a time where we do see these technologies being used widely. So here are some examples: facial recognition for passport control, voice recognition, driverless cars, and companion robots for the care of the elderly are also some things that are being trialed out. So that just gives you a sense, really, that certainly it's a field which is, although has a long history, its visibility for everyday uses is becoming increasingly so, really. And when we're thinking about artificial intelligence-based interventions, we need to think about them, at least for healthcare, as an intervention. We can't just think of them as clever devices that have been developed and therefore kind of escape the grips of evaluation that are required in healthcare as a whole. So next slide, please. So when we're thinking about evaluating AI, of course, our aim is to learn, continue to learn by using the scientific method, but what does that mean specifically for AI? So all AI interventions, no matter how sophisticated they are, kind of under the bonnet, have to pass three questions, really, have to have three questions thrown at them. One is to know if the AI intervention is cost effective, if it's safe, and does it change the resource use of healthcare? Those are and those three questions are actually not specific to AI. They're generic questions to any intervention we think about in healthcare. But perhaps AI comes with a number of challenges, really. First and foremost, it's very fast-paced. So AI kind of solutions, there must be thousands of apps out there now that will help people in one way or another, or claim to. So the pace of change is very quick. The other thing about them is that they're coming into a complex adaptive system where human beings are a part of a complex environment, making complex decisions. And so evaluating them surrounded by that complexity, it creates a challenge. And likewise, we have to think about the acceptability. Now, there is, for a lot of non-healthcare related stuff, the market is a test for acceptability. You know, either the AI technology survives the market forces or it doesn't really. But in healthcare, it's got to be acceptable to patients and the clinical staff that are looking after those patients. So the acceptability criteria is actually quite an important one. There are examples of AI systems being turned off because users just didn't find them acceptable. And another challenge is integration. So the AI system actually has to be integrated into the digital ecosystem in which it's going to work, and that integration effort is not trivial. It actually takes considerable amount of time and energy and skill to do. So the computer-aided risk scoring system I described took about 2 years for the IT department to engineer it into their electronic health record. And so there are real issues with kind of integrating AI, which I think we analysts need to be aware of. And of course, then there's product liability. Really, it's one example would be if the AI systems gave some advice and it wasn't acted on, or if it gave the wrong advice and it was acted on. How do we handle those situations? So there are some complexities for AI in healthcare. Perhaps the thing I would like to emphasize is that the importance of any intervention while it's being developed is really that it should have a theoretical basis. So we have to ask the question, how will the AI improve something or other? It's either going to improve decision making, it's going to improve quality or safety, or it's going to improve outcomes or resource use. And so when developing AI solutions, it is also part of our responsibility to articulate what that theory of change looks like, because a lot of the learning that we will experience will come out from that theory. And if analysts are not necessarily developing these things, but find themselves involved in some sort of external process where people are bringing AI into their organizations, they might want to think about their role as potentially evaluating the AI. And we suggest a concordat between the evaluation team and the AI developers and stakeholders, because it is quite a diplomatic process, really, when you're evaluating AI technology in the real world. Next slide, please. So we suggest there are, and this is not a kind of controversial, really. This is kind of based on lots of other people's work as well. We suggest that the evaluating of AI is a phased interdisciplinary approach, which and I'm going to just quickly talk through the 4 phases. Really, we suggest there's a phase 1, which we describe as a preliminary desktop exercise, which starts with a rationale, maybe some evidence review, a logic model which captures the theory of change, a demonstration, really, that the AI intervention is both ethical and safe, and a roadmap to the field, really. And if an AI technology can't do any of those things, doesn't have a good rationale or a good theory, is not ethical or safe, and so on, then it doesn't deserve to, until it can meet those criteria, it shouldn't really progress. Phase 2, we describe as laboratory testing, which is where you'll do some sort of accuracy and external validation, which is sensitivity, specificity, C-statistics, and so on, that people may be very familiar with. But actually pilot studies of using the equation, or using the AI in situ with users on a kind of pilot study basis, really, and thinking about implementation and scalability at that time. So things about, who would support the technology, what are the sort of training required, what do you do if there's a software update, how are we going to handle that, and so on. And then phase 3 would be field testing. I think it's always a good idea to at least try and start with the notion that we want to do a randomized controlled trial. I'm not saying RCTs are always the appropriate design, but they have some really beautiful features in their design, which do help us think about kind of confounding and other kind of important ideas for evaluating technology. So RCTs or other appropriate designs. And a key part of AI would also be what we call a process evaluation, where we try and understand how the human beings who are surrounding that technology actually feel about that technology, and what their views are and perceptions are on its usefulness, and also trying to capture, as often is the case, really, unintended consequences. And if the AI technology manages to go through all those 3 phases successfully, then long term, it will continue to require surveillance, just like a drug in the long term has drug safety reports and drug surveillance, and there is no difference for the AI technology itself. And I'm suggesting that that analysts will have to think about getting involved appropriately in all 4 phases, really. I'm not suggesting that an analyst does all 4 phases, but I'm suggesting that they might want to think about getting involved with all 4 phases. Next slide, please. And in the strategy unit, we are getting involved with evaluating AI, and we've built a partnership across 3 kind of different teams, really. So the strategy unit themselves, staff who are very familiar with mixed methods evaluation, the health economics unit, who are very familiar with especially big data analytics and health economic evaluations, and perhaps especially for the randomized control or kind of experimental designs, the Leicester Clinical Trials Unit. I'm not suggesting this is an ideal partnership. I'm just trying to illustrate to you the sorts of partnerships that might be required, so we can cover all bases of the various phases of the evaluation. Next slide, please. Great. I think that's me done, Gareth. I'll hand over back to you, and if there are other things, questions or whatever, I'll let you decide what.
Yeah, no, thanks, Mohammed. I know you've got to go at 10:30, haven't you? So I did wonder, yeah, if people had any sort of questions that they wanted to pose, just in the chat box before you go. Julian has put in a query around GDPR requirements and medical device evaluation, whether you'd consider that as part of the work.
Well, I think it's really just pointing out that evaluating AI in healthcare has these multiple dimensions, and Julian's right to highlight that as well, really. So it is quite complicated. So, but it definitely needs addressing. Yes.
Okay, and we just had a question come in from Pedro. So is acceptability focused on moral issues, or does it go beyond that?
I'm not sure it's moral issues. It's more about professional ethics often, really. So if I can narrow it down to doctors might feel that their professional judgment is being compromised. Or being in some way kind of overlooked, really. So it's really the role of the decisions, the AI in supporting professionals, and whether the professionals find that acceptable, and of course whether patients also then find that acceptable. So you could imagine a doctor saying, you know, the computer says I now need to do this to you. You know, there are issues of how acceptable that notion would be, and that needs to be considered very carefully.
Okay.
Great.
Thanks, Mohammed. There's no further questions.
Great. Thank you. By all means, and people can contact me by email if you want. And I'm sorry I can't stay for the rest. I'll hand over back. Thanks a lot, folks.
Okay, that's great. Yeah, thanks, Mohammed.
Bye-bye.
Okay, at that point, we're just going to hand over to Stephen Wyatt, who's going to take us through what he sees as 3 positive changes in terms of the future of sort of strategic analytics. Over to you, Stephen.
Thanks, Gareth. I'm just going to talk about 3 changes that I think might occur in our field over the next 5 to 10 years, all positive changes. I'm a bit speculative and fairly random, but there's no particularly unifying theme for the 3 areas I'm going to discuss. And I've got some requests for you before I start. So I'm going to make a number of claims over the next sort of 10 minutes or so. Please don't ask me to back any of them up. If you do, then I might have to sort of pretend that my speakers aren't working. By all means, contest the claims I'm making, that's fine, but yeah, don't ask me to back them up. And I'm not asserting at all that these are either unique thoughts or that no progress has been made on these fronts so far. In fact, I'd say it's likely that people are working on these very issues now. And if you're aware of progress that's being made in these areas, then I guess we'd love to hear about them in the discussion later or via the chat. And lastly, please don't remind me of the predictions I'm making in a few years' time. That would be really unfair, I think. So if you could advance the next slide, Gareth. So the first area I wanted to talk about relates to the sort of daily lived experience of an analyst working in the NHS or within a sort of social care or public health setting. If I could ask you to think back to all of the teaching that you've received or the learning that you've participated in from, say, the middle of secondary school through college and university, that is of sort of direct relevance to the work that you do today. And next, I want you to think about the last 2 to 3 weeks of your work, the tasks that you've been performing over that period. I'd like you to think about what proportion of these 2 weeks, of the tasks that you've been carrying out over the last 2 or 3 weeks, were sort of directly informed by the formal teaching that you've received. Now, I could have asked this question on Mentimeter, I guess, Gareth, couldn't we? But I'd be surprised if anybody's thinking that more than half of their week has been directly informed, the tasks that they've been carrying out, been more than directly informed by the learning they've received. And even if we remove sort of admin and general management tasks from your week and look at just the analytical work you're doing, even then I would guess the number wouldn't get too much higher. And I don't think that's true of lots of other professions. I don't think we'd have the same answers if we were looking at, for example, architecture or engineering or medicine, for example. And these are the sort of tasks that I think are occupying us, really important tasks, aren't really the focus of much attention in sort of formal teaching or in textbooks, are things about the way we talk to clients about the projects that we take on, about the way we structure and scope those problems, about how we decide, given the client's constraints, whether to prioritize, for example, comprehensiveness of the analysis we're doing, or transparency or reproducibility. It's unlikely we're going to be able to perform a perfect piece of analysis in all different dimensions, so we're having to make choice about which things are more important to our clients. about how we document our methods, about how we wrangle or munge the data that we have to gather to perform the analysis we're going to carry out, deciding on the most appropriate graphical form for some of our outputs, working out how to draw the analysis together into some sort of coherent narrative at the end so we can communicate it back to our clients. All of those tasks are so important to the work we do, but receive remarkably little attention, I think, in formal teaching. And even if, when we're conducting more sort of technical tasks, the technical pieces of analysis, I still find that I'm making lots of design decisions or implementation decisions, which I can find very little guidance for in formal and standard texts. And this isn't just some irrelevant observation. I think all of those things that I've been talking about have a really radical and material impact on the results that we get and the advice we give our clients. Now, reproducibility is one of those sort of concepts that's become really important in data science, and I think we've made a lot of progress in that area in recent years. But its current conception is fairly limited. We think of it as, you know, if an analyst or a few analysts were starting with the same data set and ran the same analysis, then they should arrive at the same set of results. But that sense of reproducibility is, for me, is somewhat limited. Ultimately, we should be thinking about a much wider definition, something like if a manager approaches two analysts in the same business context with the same business problem, then they should receive roughly the same advice or recommendations when the analysis is complete. And I don't think we're even close to be able to suggest that we can do that at the moment within our profession. As an individual analyst, I can come to terms with that. I can just say, well, you know, I've done my best. I've taken the tasks on in good faith, and I've done all the necessary checks that I need to do. But it's a concern more for the profession than for the individual analyst in it. And I think what we're going to need to do over the next few years is substantially increase the proportion of the time that we spend in our working week, which is codified, described formally in texts. Now, I think actually some of this has been codified, but at the moment it gets remarkably little attention in the training and development of analysts. There are stuff out there on problem structuring, for example, that we could be using far more. And I'm by no means underestimating this task. In fact, I think it's a task that will never be finished. And I think there's some areas of the work we do which will be highly resistant to codification, and rightly so. But I think we can make progress from the current position. And I think if we did, that would be a really positive step forward for the profession. I know there's lots of people working on this sort of stuff at the moment. And I think over the next 5 years, we might see, 5 or 10 years, we might see some really big changes in these areas. So that's the first area I was going to talk about. Gareth, if you could maybe move on to the second area. The second area is about information systems, management information systems or business information systems. And I think these are ripe for a really radical overhaul in the next 5 to 10 years. I think what most management information and business information systems do is they help people navigate to particular types of data. If you want to find a particular sort of data, and the systems help you try and find that and do some preliminary analysis on that, you know, cut it by another variable or compare it across a certain dimension. But I think most management information systems, although they're designed for managers, ultimately end up getting used by other analysts. And that's because they don't really start from the questions that managers have. The outputs that management information systems provide are rarely sufficient to sort of really address a business need. It's like a manager asking, how do I get from Birmingham to London? And the management information system says, well, I can tell you how to get from, I don't know, Daventry to Luton, for example, a small part of that journey. It doesn't start from the original fundamental question that the manager asks. It assumes that they already know what the data is that they need in order to make their decision, and that once they get their decision, once they get that data, the decision is relatively straightforward. And I'm not sure that's really represents the true experience of managers and their requirements. I think the fundamental question sitting behind most of the analysis we perform on behalf of managers takes one of a relatively small number of forms. They are things like, did this thing that we did have the desired effect? What caused this problem that we're seeing? What of these various options that we're being presented with is the best one for us to take forward? What might happen if we were to do something X in the future? What will this look like in the future? How might we fix this problem we're facing? How could we do this process better or more efficiently? Those are the sorts of fundamental questions that managers have. And I think in the future, what we need is information systems that will be oriented around those questions and that will guide managers through the process by which they can make progress on those questions. The output might not be an answer. The output might be a specification for a piece of analysis that they need to commission. But I think the fundamental change needs to be that management information systems need to start from those basic questions that managers have, rather than with the assumption that the gap at the moment is a piece of data that somebody needs in order to be able to progress a piece of work. So that's my second area. I think there's going to be maybe massive change in the way in which management information systems are structured and organised. And this last area is about is a bit specific, but I think it will be a really important piece of progress if I'm right. So over the past 20 years, there have been two analytical paradigms that have been developed and have really flourished in data science. The first is around predictive analytics, and the second is around causal inference. So predictive analytics, I'm talking about scenarios where we might seek to estimate the quantity of a particular variable, given a set of other variables and a set of observations that we might have. And this form of analytics is kind of dominated by the progress that's been made in statistical and machine learning over the past few years. It's not the only set of questions that machine learning focuses on, but it's the dominant question I think that machine learning considers. And so all the progress that's been made in terms of defining test, train and validation data sets, all the performance metrics that we've developed, C-statistics and recall and sensitivity and accuracy, Bria scores, etc. And all of the new forms of machine learning that have been developed to give us good predictions, taking us beyond sort of more basic forms of regression and decision trees through to random forests and support vector machines and Bayesian methods and neural networks, etc. That's the sort of area that I'm describing when I'm thinking about predictive analytics. And I think that area has really progressed over the last 20 years. The second area is causal inference. So this sort of, this piece of analytics is focused on trying to explain the causal relationships between several variables of interest. And for a long time, the statistical profession has sort of stood back from this question with the sort of standard refrain that correlation doesn't equal causation. They've kind of implied that statistics isn't the place to be drawing causal inferences. That's the job of philosophers and social scientists, maybe. And over the last sort of 10 or 20 years or so, a number of sort of brave people have kind of been contesting that view, suggesting that in the reality, what most statistics is trying to do is trying to draw causal relationships. That is the fundamental question that we're trying to address. And actually, some of this might be much more amenable to analysis than we first thought. And the main developments in this area have been the development of causal diagrams and directed acyclic graphs, analytical approaches to interrogate those causal diagrams, and a series of sort of quasi-experimental study designs have been developed to sort of underpin this area of work. Matched cohort studies, interrupted time series analysis, regression discontinuity designs, synthetic control study designs, panel data methods, instrumental variable approaches. All of those are attempts to draw causal inferences from data. So that's been a really big area of development over the past 20 years. Now, I don't know, I wouldn't regard myself as an expert on either of those. I know enough to be dangerous on both of those two fronts. And if I was a young analyst starting out, I'd be thinking about which of these two two paradigms I'm going to sort of try to become more expert in the future. I think these are the two dominant forms of statistical advance we've seen recently. So one of the things that seems from the outside is that these two areas are developing largely independently. But I wouldn't be at all surprised if some clever academic finds a way of synthesizing these two developments into a single unified approach that brings together all the learning we've seen on causal inference and all the learning we've seen on predictive modeling into a single paradigm, a single approach. And I think that would be a massive step forward for analytics, maybe in the medium to longer term, and something maybe to look out for in the academic journal press. That's all from me, Gareth. They're my three thoughts.
Okay, no, thanks, Stephen.
A few queries coming in, but I don't know whether we want to pick those up now or at the end. But,
yeah, I was just conscious of time, really. I think there's a couple of good sort of observations in the chat from Simon and Rich. I just wondered whether you could maybe respond to those just while Julian's sort of talking, just so we get to hear from him as well. So yeah, really valuable there, Stephen. Thanks for that insight. I'm just going to move us on now, just to introduce Julian. So Julian Flowers is PHE's head of data science, and he's just going to talk from a more of a sort of data science perspective, just in terms of how he sees the future of health care analytics. But Julian, can I just hand over to you at this stage? I'll drive the slides if you tell me when.
Okay, thanks a lot. Okay, thanks. Thank you, Gareth. So I'm going to take a slightly more strategic view and step back. So look at the first slide, please. So just a bit of preamble. So health and care data is huge, estimated in exabytes or yottabytes or brontobytes or whatever. It's one of the biggest sort of sets of data there is. It's hugely valuable. So I found a couple of things. So apparently a care record is worth about $250, a single care record on the black market. So people are very interested in it for financial reasons. And there's a lot of estimation work going on about the value of it. I think a lot of care data is not collected by people who are data collectors. The doctors, nurses, clinicians, they're not really data collectors. So you just need to bear that in mind. And then we've got the whole kind of generation of data coming from machines that we use and so on. And I think the future is now, really, or it always is now. So I've been working for the last few months on a specific project for COVID. I've been working a lot in COVID, and it's just accelerated a huge number of things. It's knocked down a huge number of barriers to the way things are done, data sharing, cloud solutions, yeah, everything. So I think that's just a bit of a background, just a bit of a preamble. Next slide, please. So I've always thought this, and I think these are the sort of problems as I see them for analytics, really. So one is what I call the discovery problem. So there's vast amounts of data out there, but how do we know what's out there? How do we find it? How do we know it's relevant? There's an access problem. If we can find stuff, how do we actually get hold of it? If we can get hold of it, then usually what I call the munging or the wrangling problem is that a lot of the effort goes into turning it into something we can actually use. I mean, it is said 70% of an analyst's time is spent on cleaning and reformatting data. Still a bit of a problem, although there's tools to help us do that a bit more. And then the product problem. So if we can get hold of this data, how do we best turn it into useful analyses, products, things that can be used and shared? And then finally, the maintenance problem. So we've been doing a lot of product building, but once you've built something, you've got to keep it going. And that sort of relates to the reproducibility issue that Steve was talking about, and also a whole set of kind of software thinking that might be necessary, like Git repositories and open data thinking and those sorts of things. Yeah, somebody's mentioned the garbage problem, which is also true. Just because it's there doesn't mean it's any good. So here's kind of 5 ideas that might help analysis in the future. The first one is is just getting our kind of data stores and metadata catalogs sorted out. And there's a lot going on in this space. We're doing something in PHE about describing the data we have in some sort of degree of granularity and trying to build some search engines so we can help people find what we've got. It's been a major problem in COVID because we've had lots of cells and they're all creating their own data sets and nobody really knows what they've got. So you never know who's got what. And that, metadata sort of went out, it was big in the early part of the 2000s, went out of favor, but now it's really important. We've got to get this sorted out so we can share things properly. There's this idea of new analytical teams, so not just having people do analysis, but working in conjunction with the influence of digital and with sort of data engineering and so on product building, and particularly the ways in which people access data is changing. So APIs and big data and so on, and those are all kind of skill sets that people they're not common, and we don't tend to work in teams like that. I think there's a lot about open data models, which I'm not terribly familiar with, but they involve all of these things. I think one of the things we find is we need to build some sort of data culture. Data is definitely, the word data, probably since COVID has begun, the word data is probably used 100 times more than it ever was. Everyone wants the data, and people are genuinely much more interested in it. But there's a big gap between the analytical world and some of the sort of senior management world about the art of the possible, about generating answerable problems and so on, sort of being quite open, sharing. And then finally, we've got, I think Stephen said that people who are trained in one way are no longer doing that. We've retrained a lot of our analysts to program now, to be more agile, to use version control systems. All of these sorts of things are really important, I think, in building capability. And none of this is to do with AI. There are some fundamentals, I think. I mean, there is a model I've seen of, there's a kind of notion of swimmers, scuba divers, deep sea divers. You probably don't need that many people who build AI systems, but you probably need a lot of people to understand them. So, and we know some things won't be a problem in the future. We won't have any problem with storage, scale, compute, power. It's just not an issue. I think we need to, the data, I kind of think about the 3 L's, linked, longitudinal, and labeled. So obviously one of the things about AI is you have to have labeled data, and how we don't really do that very much. So we don't really have, well, certainly in public health, we just have no training data sets. We have to get some. I don't think we'll be using fixed infrastructures. I mean, that's happening right now. Things are moving to the cloud. And I think a lot of stuff that we've routinely done in the past, we just won't do. It'll be automated. Reporting, all that kind of thing. It already is being automated. And I think probably AI has quite a big role in that. For example, in improving data, so not in sort of building fancy systems, but in assisting analysts in doing their job, and enabling a whole kind of bunch of stuff that we currently don't do. And finally, I think we use the data we use in healthcare, and how we use it will increasingly be, we need to engage with the public. Public trust is going to be really, really important. And the regulatory framework that we operate in, again, will be really important. I don't know if I've got any other slides. I think that's probably it. So, and this is just, these are just supplementary slides, so forget about that. This is just basically, this is our data pipeline for the public dashboard. If you go to the next slide. And this is our architecture, which is pretty complicated. So this is a public data product which serves up, COVID data to about 500,000 people a day. And that's what you need to have to do that. So, so I just thought you might be interested. That's what we've sort of built in the last few months in order to service about 30 million requests for data every day. Okay, that's all I have to say. I'm conscious of time.
Okay, yeah, thanks, Julian. No, it's been really sort of valuable insight, and yeah, lots of sort of thought-provoking stuff, and yeah, good sort of food for thought, sort of building upon what Mohammed and Stephen have also talked about as well. So that's great. So we've heard from each of our sort of different perspectives in terms of how they sort of see the future. I just wanted to bring us back to the Mentimeter content at this stage, please, and just based on what you've heard from our sort of three experts, just if we could have a think about sort of addressing these couple of questions. The first one was around what do we consider to be the key opportunities for those working in health and care analysis in the future. So I can see a few people already slotted in some thoughts there, but maybe if you could just take a moment or two just to input there. If you need the Menti code again, it's just at the top of the screen there. In terms of what's gone in so far, definitely a focus on sort of better access to more integrated data sets and better data linkage. Couple of comments there around sort of better access to high quality data. I think building on from Julia, a few of Julian's points. Useful comment there on less transactional reporting. So again, I think that's one element that we'd like to see sort of automated routinely, so that analysts can sort of focus on some of the more sort of strategic problems and trying to sort of build responses to. I don't know if Stephen and Julian, you've got any sort of other thoughts that you wanted to feed in there, just in terms of the feedback we're getting from the audience.
I don't disagree with any of it.
Yeah, I think they're all sort of the sorts of things that we'd expect. I think they're good observations.
I think that probably one of the big things is that is going to allowing analysts to analyze. So really getting the heavy lifting and the number crunching and all the routine stuff to run itself, or to move the heavy lifting into sort of data environments.
I think that's the big sort of opportunity for me is actually have an analyst sort of focus on the the interpretation and the translation of what the data's saying. I think you mentioned a lot of analyst time is spent data cleansing and manipulating data, and I think there could be more of a focus on interpretation of what it means and how it can provide insight. That's where hopefully there'll be a bit more focus on in the future. Okay, if I can just bring us on to the next question now. So this was around what we see as some of the key challenges. So I thought data sharing might come up there. Big exclamation mark next to it. That's obviously one area that if we're going to work with better integrated data and have more data linkage, that's going to be fundamental. The sort of automated machine learning aspects, again, the risks attached with that, again, to sort of potentially around misinterpretation or lack of interpretation. Information governance, getting that public engagement around sort of confidentiality, access to health data. Probably one there maybe for Stephen around sort of transparency and methods. That again, as part of the DSU arrangement, we're trying to develop much more of a better mechanism for sharing code across different systems. So potentially one system could replicate some analysis that's been done elsewhere. So that'll hopefully help with the transparency aspect. Data ethics, yeah, good observation there. I think the ethical sort of considerations are going to be really key to some of this in terms of, yeah, sort of how inclusive those sort of future algorithms are and how they work. I don't know, Stephen, whether you want to just come in and comment on any of those aspects.
Obviously, some people, I think, rightly concerned about, you know, whether some of the stuff that's going on in the private sector at the moment, maybe the big tech firms and the practices they take on, whether that might damage public trust more generally in the analytical profession, and therefore our ability in the public sector to use data for good purposes. I think we've got a question. There's a question for us in that as well, in that we have to be squeaky clean on some of these practices and making sure we do have all of the relevant legislation and documentation and use cases well documented before we start pieces of analysis that might be considered contentious. It's just too much to risk. It only take one or two big stories about misuse of data within the public sector for us really to take big step backs in that area. A little bit worried about at the moment about the sort of broad, wide sweeping freedoms that have been granted under COVID, and whether there's a few things happening maybe under the radar at the moment that might come to light in the next few weeks and months that people might be worried about and might receive some more public and media attention. So I guess over the next few months we just have to make sure we apply our own ethics and judgments to the things we're doing, as well as just thinking about whether or not the current legislation allows it.
Yeah, there's a useful comment here in the chat around yeah, a recommendation in terms of for better understanding those sort of trust, ethics and public engagement issues. There's a link there that colleagues recommended. Okay, I think some really useful sort of risks and challenges there that we can sort of take away and reflect on as part of the decision support arrangements in the Midlands. That's really helpful. I just had a couple of final questions just for you to consider. So if you could change one thing which would improve the way you work and operate in the future, what would it be? It can be in relation to any of those sort of points that have been mentioned previously, or anything that our speakers have raised. What would be the one sort of thing that would help you work in the future? A little bit of time to reflect on this. Access to data, better use of version control software. Obviously the impact of politics. Having worked within PHE over the last few months, I can definitely relate to that. Trying to break down silos between different organisations and teams. Data integration again. More of a focus on freeing up time for more of that exploratory analysis. Start small, fail fast line of thought. That's definitely some of the sort of way of thinking that we're trying to approach the DSU work in the Midlands again. But more automated processes. Trying to free up resource to do more of that narrative and interpretation. Education of decision makers, so there's a sort of analytical leadership aspect that we're trying to make some steps forward with as well. Some really useful stuff there. Just conscious of time, I know I've got one final question on Mentimeter. So in terms of what 3 words would you use to describe how you feel about the future of analytics in health and care, based upon what you've heard this morning over the past 59 minutes or so? Or any sort of previous thoughts you've got? I've hidden the results for now, just so I don't bias your responses. But if you could maybe just enter 3 keywords that just display how you feel around all this, and it'll just generate a nice word cloud, hopefully. I'll just give you a moment or two. A few responses coming in now. Okay, so I've just presented it there. So yeah, challenging in big letters in the middle. Wouldn't argue with that. But yeah, a certain degree of hope and optimism. That's really good. Exciting is quite prominent there as well. So on a positive note, nice way to finish. Okay, I'll just leave that open while people can just respond so we can build that up. We've reached the end of the hour now. So really I just wanted to take the opportunity just to thank our key speakers, so Mohammed, Stephen and Julian. Thanks very much for joining us and contributing with your expert thoughts and insights. Really valuable, really good stuff in the chat function as well, and plenty to take away and reflect on. So yeah, at this point I'll bring proceedings to a close. I hope you enjoyed it, and hope to see you on subsequent sessions as part of the Insight 2020 Festival.